Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Mathematical dilations are basically when you go to a copy machine and you take something that's small and you make it bigger, or you start with something big and you make it small. So it's either going small to big or big to small. Both of those are considered dilations. I know that a lot of times when we think about our eyes dilating at the eye doctor, we only think one direction. But we're just going to go ahead and say, in general, a dilation is when you change size. Now, this is not going to be a rigid transformation because something's going to change size. Okay, so let's just go ahead and let's start with an image or pre-image, and then we're going to get an image. So remember, your pre-image, if you remember transformations, is going to be labeled triangle ABC. And your image will be triangle ABC with the little marks. And let's just draw a triangle. And I'm going to go ahead and I'm going to give us a point P to do our dilation from. And we're just doing a rough dilation right now. We're not actually saying what percentage or whatever on this. Okay. So we're going to call point P our point of dilation. So the first thing that's good to go here is that we're going to need a straight line from each point to P. And is this long enough? It is long enough. What do you know? Okay, so you'll see that, right? And then someone might decide to make this half the size. And I'm just gonna just estimate this. So about the middle of that line, about the middle of that line, and approximately the middle of that line. We're gonna go through actually how to do it here in a minute. But I wanted to just give you a rough image so that we can talk about this. So this would be an example of, we can actually see here that the triangle has shrunk. In this case, P is our center of dilation, and we have a scale factor, okay? To find that scale factor, we would compare the respective side. Okay? Your scale factor is always going to be your new length over your old. So you could do the side AB compared to the side AB. It should be equal to the side AC over AC, which should be equal to BC over BC. If they're all three the same, then you know the same ratio, then you know you would have a scale factor or a dilation. And they create similar triangles. They're not congruent triangles anymore because the lengths of the legs are not the same. Okay, so in this case, because it got smaller, our scale factor is less than 1. Okay, so if your scale factor is between 0 and 1, it will get smaller. And if it's greater than 1, it will be larger. I say 0 to 1 instead of strictly less than 1 because I don't want to talk, negatives are not a thing with that. Okay? So we are going to go ahead and we're just going to walk through how to dilate something from a point, and we're actually going to go ahead and do it correctly. So we're going to draw Q, and we're going to draw a random quadrilateral, not a parallelogram, things like that. We're just going to do a random quadrilateral. So here's Q, and then 1, 2, 3, 4. Okay, and we'll call this W, X, Y, Z. And then we are going to triple, or use a scale factor of 3, W, X, Y, Z. That's what we're going to do. Okay, I'm going to need a longer straight edge. So I also like this one that is see-through. I'm just going to extend Q. Let's get on straight here. Okay, then I'm going to do Q to Z. Get straight there. Keep in mind that sometimes the width of your dots or whatever on your paper can mess you up. There's Q to X. And Q to Y. So this was for W, Z, X, and Y. I've made myself a little bitty notes at the bottom so I can remember. Okay, so we're tripling this, right? So the first thing we need to do is we might need to measure, ooh, hey, that was fortunate. Q to W is right there. So that's from Q, 1, 2, 3. That's how you triple that segment. So the new W would go right here. Okay. Q to Z. I'm thinking I should redo that line. It doesn't look quite right. Let's get a little more accurate. There's that pencil. Okay, it wasn't off by much, but it was a little, so fixing it's never a bad idea. All right, so we're gonna come out and find that length from Q to Z. So there's 1, 2, and 3. Bring that up so you can see. So here's our new Z, right there. I'm gonna do Y first, because that way it's closer to where I'm at. A little bit further out, there we go. 1, 2, 3. I'm really gonna have to bring this back in for X. See what I can get done quickly here. Off the screen, bring it in a lot more. There's 1, 2, 3. Okay, once you have marked, after you've drawn all of your lines and then you've marked your points by tripling each segment length, now we can connect W, X, Y, Z. And now we should have, each of our segment lengths should be triple what they were before. So if this is 4, this is now 12. So it's just that kind of thing. Now our angles are congruent, okay? So angles are congruent. The sides are multiplied by the scale factor. The segments, or you can call them segments. Okay, and you're going to see this by, it'll say D in comma C, or dilation, scale factor, center. And a lot of these are not done on blank canvas paper like this. They're actually done on grid paper so that you can actually get coordinates. So grid paper will make this easier, but we're going to go ahead and we're going to reevaluate that first method again. And then we're going to compare. So here I have to dilate, and I want to double my image is what this 2 is saying, and my point of center is the origin. So from the origin, I'm just using slope to draw my line instead of getting a straight edge. Okay, there's that, right? With C and with A. So we can draw that straight line out from each of them, right? Now, I could get my compass and actually measure the segments, or to do it, I just need to go dilate twice, right? So 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 1, 2. One, 1, 2, 3, 4, 5, up 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Whoops, 4, down 1, 1, 2, 3, 4, down 1. Ooh, my guesstimate of a line. It's not drawing well. So in this case, I just kind of eyeballed the lines, and you guys can see now why I say I'm not perfect at drawing. Okay, but I use the slope, right? I use the slope to double each segment. But let's look at the pre-image versus the image now that we have it, and just look at the ordered pairs. So our pre-image, A was left 4 and down 1. B was 2, 4. And C was 5, 1. Okay. If you look at the image, A became -8, -2. B became 4, 8. And C became 10, 2. So what I like whenever you're doing it with coordinate geometry is that you can, if it's around the origin. If it's not around the origin, you can't really do that. But if it's around the origin, you can. You can just take the coordinates and apply the scale factor. Our scale factor was 2, so just multiplying everything by 2, and it kind of worked out. So that was kind of a nice thing that we could do. What happens when the coordinate isn't on graph paper or on a coordinate plane? What happens when we're just given a random point? Okay. I'm going to go ahead and draw a rectangle. And let's make it a taller rectangle. 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay. And I'm going to draw a second rectangle. You might notice that I did a scale factor of 3, or a third, because I went from A, B, C, D to A, B, C, D. Where's the point or the center of dilation, though? Where is the center of dilation? We know the scale factor is 1/3 because I drew it on grid paper. Okay, so to get the center of dilation, we're just going to kind of reverse what we still got to do. We know that these had to be on the same line, right? The A's had to be on the same line. We also know that the B's had to be on the same line. We also know that the C's had to be on the same line. So I'm just matching up the C's. And we know that the D's had to be on the same line. And I might have got off with my pink line. It looks like I did because the other 3 are perfectly right there. Did I get off with my pink line? There's a... I did. There we go. Yep. So right here, when I drew all 4 lines connecting the pre-image to its image, all the lines came through the same point. Now we know where the point of dilation was because it's where all those lines came together. So not only can you go ahead and dilate something just by drawing the lines, you can also find the point where the dilation was created by drawing the lines. So that's a big relationship with dilations, is that you need that kind of shooting image. And we can use those lines to kind of telescope us out or bring us back in. So if you're an art student and you have a better way of explaining it, go ahead, drop it in the comments and help me out, because I definitely did not do the best in art. I definitely went ahead and stuck with my math and science.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.